What's up, guys? Welcome back to another video. So guys, in this video we're going to be looking at this idea of inverse variation. And so that's going to be where we have a function or an equation of this form right here, where y is, I guess you could think of it as in the numerator of a fraction, if it's y over 1. And then on the other side of the equation, x is in the denominator of a fraction. And then a is just some number a. All right, so it has to be in this form for there to be inverse variation. And of course, if we multiply that x over, then we would get this form here, x, y equals some constant a. So either one of these forms, if you see either one of these forms, that's going to be inverse variation. So let me give you a few examples and let's see if you can determine what it is. So first of all, how about this one? xy equals 5. xy equals 5. So is that one an example of inverse variation? And we can say yes, it is. Yes, it is. If we divided the x over, then we would get we'd get y equals 5 over x. So it fits this form right here. It also looks just like this right here. xy equals some number, xy equals 5. So this does represent inverse variation. Okay, what about this example? Y equals x minus 4. How about that? And no, this is not an example of inverse variation. It does not fit this form. So this is not. It's not inverse, it's not direct. This is just not an example of that. Okay, so we'll put an X by this one. We'll put a check over here. I guess that X might be a little confusing, but just, we'll put a little star there. No, it's not. Okay, I'll give you one more. Y over 2 equals x. So we're like, at first we're kind of like, it kind of looks like this. But if we multiplied the 2 over, we would get y equals 2x. Y equals 2x. That's, if we're solving for y, we need y equals a over x, not 2. This is a no. This is a no. In fact, this is what we could refer to as direct variation, which is kind of the opposite of inverse variation. But no, this does not fit this form, so this is not inverse variation. All right, let's look at one more thing now. Let's say we have a data table. So let's make ourselves a little data table here. And I'm drawing with my mouse, so you'll have to forgive me, guys. And then let's say we've got x and y in our data table. And let's do 4 different ones. So let's do something like this. And let's put in a 2, 4, 6, 8. I'm just putting in random numbers here. But we're going to see if this represents a direct or an inverse relation. An inverse relation. All right, so here we go. We got a data table, and we want to know if this is going to represent a direct or an indirect or an inverse variation. Sorry, guys. So here's the idea. We want the constant when we multiply x and y for inverse variation. When we multiply x and y, we want to get some number a, and we want that to be a constant number. So here's how we can check this data table. If we multiply x times y and get the same number every time, a, then we know we're dealing with an inverse variation. So 2 times negative 12 is negative 24. 4 times negative 6 is negative 24. 6 times negative 4 is negative 24. And I think I meant this one to be a negative 3. 8 times negative 3 is negative 24. So you can see, since we're getting the same number every time when we multiply the x and the y, this is an inverse variation. This is an inverse variation. Now, what if I go in here and change these numbers? Let's do a different problem now. So let's change these numbers up and check one more. So let's do 1, 2, 3, 4 in our x's, and 2, 4, 8, and 16 in our y's. All right, now let's multiply them. 1 times 2 is 2. 2 times 4 is 8. You can already see these aren't matching. These aren't the same number. 3 times 8 is 24. 4 times 16 is 64. So you can see immediately these are not the same number. These aren't the same number. So this is not an inverse variation here. This is not an inverse variation. So that's how you check, guys, to see if we're dealing with an inverse variation. Now we can also see if this is a direct variation. Remember, direct variations are the opposite. So instead of multiplying, we can divide y divided by x, y over x, to see if this is a direct variation. So 2 divided by 1, we'll put in another color here. 2 divided by 1 is 2. 4 divided by 2 is 2. 8 divided by 3, oops, well, now it's messing up. 8 divided by 3 is not 2. And 16 divided by 4 is 4. But if we were getting the same numbers when we divided them, then that would be an example of a direct variation. But guess this one isn't working. I thought it was, but guess not. So this is not an inverse variation. It's not a direct variation either. All right, let's look at one more thing. Let's say that x and y vary inversely. Okay, so let's just go ahead and say that these two things are varying inversely. And when y equals 4, we'll say x equals 3. All right, so that's one pair right there. When x equals 3, y equals 4. And what we want to do is we want to write an equation that relates x and y. So we want to write an equation like this. So the trick is we need to figure out what a is. We need to figure out what a is. And we can do this because we know what x and y are. So if we look back up here, if we multiply x and y, we can figure out our a. So let's do that. X times y is 12. So a, in this case, is 12. So then we can write our equation. If we want to write it in this form, we can. Right here, we'll write it in this form. So do y equals a over x. So we'll do y equals 12 over x. Y equals a over x. And that's how you would write an equation, guys. If you ran into a problem where they said write an equation for an inverse variation where y equals some number and x equals some number, you would need to figure out a first by multiplying the x and the y, and then you could write your equation based on one of those forms. Okay, so the x and the y stay as x and y's, and the a you replace with that number. Anyway, guys, I hope this makes sense on this idea of inverse variation. If you have any questions, let me know. Hope you enjoyed the video, and guys, I'll see you next time.